Okay, so today we learned how to factor a polynomial completely using the greatest common factor and the sum and difference of cubes. So, numbers 1 through 5, we're going to factor each polynomial completely. So you're looking to take out whatever they have in common. So between 2 and negative 32, they have a 2 in common. So I would factor that out and get x squared minus 16. And then this is the difference of two squares. So your final answer would be 2 times x plus 4 times x minus 4. Have to keep factoring if it can be factored. The next one, they have a 6 in common, so I'm going to factor out a 6, and I would have x squared minus 4z, minus 4z plus 4. And then this can be factored still, and it would be into z minus 2 times z minus 2. So you have to keep factoring that as well. And the next one, they have an x in common, so I'm going to take out an x, leaving me with x squared plus 10x plus 24. And then this can still be factored into x plus 6 and x plus 4. We are constantly going back to what we learned previously with factoring. For the next one, they have a 3 and an x to the third in common, so we factor that out, leaving you with x squared minus, 64, and that's just 64. And then this can be factored into x plus 8 times x minus 8. This is the difference of two squares. Okay, so this would be your final answer. On this one, they have a 2 in common and an n to the fourth, leaving me with n squared minus 12m plus 32. Okay, and then that would end up becoming m minus 8 and m minus 4. So that is factored completely. All right, so at this point now, we are going to go to the sum of two cubes. So the first question on here is to write the actual formula for the sum of two cubes. And so when it's a sum, you're going to do a plus b as a binomial, and then times the trinomial a squared minus ab, and then plus b squared. Okay, so you need to know what a and b are for sure. All right, so in question number 7, a is an x, excuse me, and b is actually a 2, okay, because here I did x to the third power, and here I did 2 to the third power. So my a is x and my b is 2, which means that when I put these together, I'm going to do x plus 2 times x squared minus 2x, do the a times the b, 2 times x, okay, and then plus 2 squared, which is 4. So this would be the final answer. In number 27, you're looking for perfect cubes. So 27 is actually a perfect cube of the x. So this is actually, a is actually 3x. I'm sorry, 27 is actually a perfect cube of 3. And then x is a perfect cube of x is the perfect cube on x cubed. So 3x is my a term. And then 4 cubed gives me 64. So my b value in this problem is 4. So I'm going to do 3x plus 4 times, now 3x squared becomes 9x squared, and then minus 3x times 4, which is 12x, and then 4 squared, which would be 16. Okay? Then we have the last two problems are a sum or a difference of two cubes. And so the formula for the difference of two cubes is a minus b times times a squared plus ab plus b squared. So it looks similar, okay? So in this problem, this is x cubed minus 4 cubed. Sorry. So that's an x and a 4. So we're going to have x minus 4 times x squared plus 4x, and then plus 16. Okay, now notice that my b value is 4, not negative 4. Okay, the minus mean comes in from the difference of two cubes. Okay, on this one we have to factor out first with the GCF, and when we do that we get y to the third minus 43. And so now we have the 2y squared, but then our a value is y, and then our b value is what number cubed gives me 343, and that is 7. So we're going to have 2y squared, and we're going to have y minus 7, and then y squared plus 7y, and then plus 49. So all three of those terms have to be